This video, I'm going to look at answers from number 18 and number 20 from section 9.9. So let's take a look at those two problems. First of all, number 18, they give us a line here. They don't tell us the equation of the line. Interestingly, they don't tell us where the y-intercept is or where the x-intercept is, or for that matter, any of the points. They do tell us the slope, okay? The slope of the line is 5/8, all right? And they ask us to find the tangent of angle BAC, which of course is going to be the tangent of this angle right here, okay? There are a couple ways you can do this, but I think the important thing to remember here, the first time I did this problem, I thought a whole lot about, I don't know coordinates of any points, and that's a huge problem. But something you want to remember is that a slope is really a ratio, okay? You're comparing a rise and a run, okay? And that rise and that run will continue between any 2 points on a line. And so, I can start at this point here and I can say, well, okay, this line is supposed to have a rise of 5 and a run of 8. Now, I don't necessarily know that my rise is 5 and my run is 8, okay? I don't really know that. However, there should be a right triangle created that has that rise and that run. So if I have a run of 8, let's say, and then a rise of 5, maybe it's something kind of like that. It could be inside of that triangle, it could be outside of that triangle. Doesn't matter though, because that angle measure is going to stay the same, okay? So, maybe I have a rise of 5 here and a run of 8 here, and maybe this is a rise of 10, and that whole thing's a run of 16. The fraction is still going to simplify down to the same thing in the end. So it doesn't really matter whether or not it's inside the triangle, the actual sides of the triangle, or outside of the triangle. So anyway, it's using that same angle. So we have a rise of 5 and a run of 8 being formed with that line, and we have that angle involved. Remember, according to the SOHCAHTOA rules, tangent is opposite over adjacent. So we've got an opposite side over an adjacent side. The opposite side here would be 5, and the adjacent side is going to be 8, and that's the tangent of angle BAC. And one of the interesting things that you can take away from this, the tangent is actually the slope of the angle being created between the line and the x-axis, which is kind of an interesting idea. And by the way, if you want to know this angle measure now, remember you can use inverse trig functions. You can take, it's called an arc tangent or an inverse tangent. You can take the inverse tangent of 5/8, use that second key on your calculator, and you could actually figure out what the angle measure there is as well. So pretty neat, a little bit of a connection between graphing and right triangles and trigs and trig and angle measures. All right, number 20. They give me, it's a rhombus, and they tell me the perimeter is 60. So I know that I can divide 60 by 4. Rhombuses have 4 congruent sides. All the side lengths are 15. So once again, make sure you've got a good sketch. Make sure you've drawn things in. They tell me the diagonal is 15. And when I was doing this problem for the first time, I didn't know which side was, which diagonal was that? Is that the long one or is that the short one? So, not really sure. I'm going to make it the short one, okay? So I've got a short diagonal going in like this. And of course, they're asking you to find the sine of angle PQS, which is this angle up here. Now, the other thing that comes into play, remember when you're finding these trig values, you're supposed to be working with right triangles. And I don't have any reason to believe that there are any right angles here. So the question, of course, is where am I going to get right angles in a rhombus? Remember, they gave us a diagonal. We know something about diagonals of rhombuses. Diagonals of rhombuses are perpendicular bisectors. They break rhombuses up into 4 congruent right triangles. So I have no idea if that's what I'm supposed to do here, but it seems like maybe that might be a good idea. So I decided to make this my diagonal first, okay? And as a result, that's going to be 7.5, that's going to be 7.5. We got a right triangle here. Now, they want me to find the sine of angle PQS. We have another problem here, which is that, PQS is this angle right here. Never mind, that's part of a right triangle. So we're good. We've got a right triangle involving the angle that we need, okay? Remember that sine is opposite over hypotenuse, all right? And so if we go to this angle here, well, look at this. We have the opposite side, and we have the hypotenuse. It's 7.5 over 15. And again, don't disappoint your elementary and middle school teachers, you don't leave a decimal as part of a fraction, okay? So you could multiply both of these by 10 and get 75 over 150, or you could double both of these and you could get rid of that. That would give you 15 over 30, and some of you might have just noticed that's 1/2, okay? So the sign there is going to end up being 1/2. Now, you may be looking back at this going, now, wait a second. Didn't it ask me to find 2 possible answers? Where's the other answer come from? Well, if you remember when I was first looking at the problem, I didn't actually know where the short diagonal was and where the long diagonal was. You know, I just drew my picture and I stuck one in. Maybe this diagonal had a length of 15, okay? That's possible too, okay? If that had happened, nothing else is changing position. So if this diagonal is 15, you'd have a 7.5 here, and you'd have a 7.5 there, okay? And you would need to use the Pythagorean Theorem, basically, to try to figure out the missing side of this right triangle, because we need a sine, we need an opposite, and we need a hypotenuse. Now, I will mention one thing here. You could use the Pythagorean Theorem, and you could go through 7.5 squared plus x squared is equal to 15 squared, and you could solve that. I want you to notice something from when I did this problem before. I think the visuals work a little bit better when the 7.5 was here. Remember, 7.5 is half of 15, okay? We've seen that pattern before. Remember, 30, 60, 90 triangles, the short leg is half the length of the hypotenuse, okay? So the 7.5 would be here, the hypotenuse, it's being doubled to get that. Remember, for 30, 60, 90 triangles, you multiply the short leg by radical 3 to get the long leg. So you'd have a 7.5, a 7.5 radical 3, and a 15. And you know, if you needed to find a tangent or a cosine or something like that, you could have done that. Anyway, and that's interesting because that tells us, for example, that in this setup, this would have been a 60-degree angle, that would have been a 30-degree angle, and so on. And there's all kinds of other stuff you could figure out, okay? Now, in this setup, my diagram actually matches the labels that were given to me, okay? Unfortunately, when you move the 7.5, if I put the 7.5 here and the 7.5 here, it doesn't really match my picture very well. The leg is still half of the hypotenuse, okay? Remember, that leg that's half the length of the hypotenuse is opposite the 30-degree angle, okay? So what's happening is, this would be your 30-degree angle, and that would be your 60-degree angle, and visually it's just a little bit tough to see that because that's not how the picture was drawn, okay? So really, it would make a lot of sense if you tried to redraw your picture, and I'll probably mess this up, but let me see if I can do it the other way. We want to have the small angle going the opposite direction, because they didn't tell us where the big angle was and where the small angle was, right? We just had to draw a picture and just hope we had something that worked out. So anyway, you've got PQ was an R and S, and we've got the diagonals in here, and we knew this side was 15, and this time we were going to make this diagonal the 15, okay? We got a 7.5. They wanted us to find the side of PQS, and your right triangle's there. So that's a little better picture. Now you can see this looks a little more like a 60, that looks a little bit more like a 30, and you can kind of go from there. Anyway, long story short, either you can use the Pythagorean Theorem to find that missing leg, or if you notice that's a 30, 60, 90 triangle, double 7.5 to get 15, multiply by radical 3 to get that long leg. And you know, it's the same leg lengths as the other picture, it just didn't match the diagram very well. It's kind of visually misleading, okay? So in this case, it's the opposite over to the hypotenuse. The opposite is 7.5 radical 3. The hypotenuse is 15, okay? And once again, 7.5 over 15 simplifies to 1/2. So you've got 1/2 radical 3, or in most cases, we usually write that as radical 3 over 2. That's fine, but radical 3 over 2 is probably what you would see in the back of the book. So 2 possible answers, just depending on whether or not the 15 diagonal is going this way or going that way. Hope that helps on those 2 problems.